Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss a modified version of delta modulation, which is called adaptive delta modulation. Now before we start, let us quickly recall the drawbacks that take place in delta modulation. There are two important drawbacks that we had discussed. The first drawback was slope overload error. Now this drawback occurs when m of t either increases or decreases with very large slope. In that case, m cap t cannot catch up with m of t because m cap t increases with fixed step size. Because it cannot catch up with m of t will keep increasing and m cap t will increase or decrease with the fixed constant step size, and hence the gap between m of t and m cap t will also keep on increasing. Hence m cap t will not be able to follow m of t properly, and that was the slope overload error. It will happen if m of t is increasing very fast or decreasing very fast. Now if you recall the waveforms that we had drawn in delta modulation, how will you understand that the slope overload error is taking place? So let us take a simple example to understand this. If let's say m of t is increasing very fast, on the other hand let's say m cap t is increasing with fixed step size, you can see m cap t will always remain below m of t, and hence the output of comparator and hence my final digital output will be nothing but continuous stream of logic 1. So when you get continuous stream of logic 1 at the output side, this tells us that the slope overload error is taking place right now because your m cap t is not able to meet m of t at any point, and hence you are getting continuous stream of logic 1 at the output side. Now this will be one case. On the other hand, it may also happen that my m of t is now reducing very fast, and in this case m cap t can keep on decreasing at constant step size again, but it will not be able to catch up with very fast decreasing m of t. And in such a case, you can see m cap t will always remain above m of t, and hence this time I will get continuous logic 0 at the output side. So when you get continuous logic 0 the output side, this again indicates that the slope overload error is taking place. The second drawback that we had discussed was granular noise. What was the granular noise? If you recall quickly, granular noise takes place when your modulating signal does not change. It remains almost constant. Now in this case, m cap t will keep on oscillating around not changing or almost constant m of t. Now in this case, you can see in one cycle m cap t will be greater than m of t, in the second cycle m cap t will be less than m of t, and hence the nature of output in this case will be alternate occurrence of 1 and 0. So when 1 and 0 keep on occurring alternatively, in that case we understand that the granular noise is taking place. Continuous alternate occurrence of 1 and 0 will indicate that m of t is almost constant and m cap t is simply rotating around m of t. So this is the indication of granular noise. So first of all, we have to understand how to read slope overload error and granular noise that takes place in delta modulation. So we read them through this simple conclusions. If there's a continuous stream of ones or zeros, it indicates slope overload error, and if there is alternate occurrence of 1 and 0, it indicates granular noise. Now the next question arises is how to overcome slope overload and granular noise. So the major reason that delta modulation cannot correct slope overload or granular noise is because the step size with which m cap t increases is constant, and hence whenever the slope overload error is taking place, it is obvious that m of t is increasing at very fast rate. So I should also make m cap t increase at fast rate. That will only be possible if the step size with which m cap t is increasing is increased. So m cap t should increase with greater step size, or in the second case it should decrease with greater step size so that it catches up with m of t and slope overload is avoided. On the other hand, to avoid granular noise, you can see that granular noise will occur when the modulating signal m of t is almost constant. Now in such a case, to avoid granular noise, m cap t should in fact change with smaller step size, because if it changes with large step size, then it is not approximating m of t properly. So in this case, the step size of m cap t should reduce. So if the step size of m cap t reduces, in that case we can make it look very much similar to m of t, which is almost constant. And in this previous case, if I can increase the step size of m of t, it can easily reach to m of t, and I can avoid slope overload error.